Let's assume most people who are supposed to be here are here. So I'm gonna start by going over the problems that we did last week. Okay. So the first problem is pretty easy. The entire goal is just to take the first line or the only line from the input and to output what it is. And so here we need to first create the scanner, in which case we'll name scanner in. And then because we're reading it from the user input, we put system.in here instead of a file. And then the only thing we have is some variant of the word hello world. So we just do string s is equal to in.nextLine. And so in.nextLine guarantees that if there are like two words, for example, it reads both of them. And the last thing we do is we just output s, print line. And then as we can see, wait, just kidding. There's no sounds. Okay, so if we submit this, we'll see that all of the test cases work. And yeah, so the only reason why I said it's some variant of hello world is so that you guys just don't print out hello world by itself. And also, if you guys have any questions about any of these problems or what I do, just let me know, because I can't see when you raise your hands or raise your hand. So
I have a quick question.
What's up?
Okay, so I know that like all these problems require like how do you know if a problem requires you to like input scanner with the file method?
So for HackerRank, for our sake, all of HackerRank will ask for you to do system.in. But for example, if you go to Usico and you do a problem, they'll tell you that the input file name is let's say like boots.in, right? In which case you would put, like in that case, you would put scanner in is equal to new scanner, new file, and then it would be boots.in. And then for competitions, like it automatically reads in this file. You don't need to create a file. You don't need to do whatever. As long as you just have this line and this file inside of the quotations is the same as they give you, you'll be fine. Does that make sense?
Okay, yeah, that makes sense. Because I was like confused because I thought there was like an input file in HackerRank, so I started to do that. Like I started to like files.
Yeah.
You understand what I'm like thinking of?
Yeah.
So then I completely messed up, and then when I did system.in, it worked perfectly fine. So
okay. Yeah.
I just have to keep in mind that HackerRank does system.in and not files.
Yeah, and you'll see like when you pull up like if it's like pre-made for you like this, usually there'll be a comment here that says read input from standard in, which would just be system.in. Okay, so yeah, okay. Okay, the next question is online school, and the question says that if you have an input of names and their score, and then you have name, score, and then like basically you're just outputting what you're given, right? So this one's also pretty easy. First we create the scanner, and it's from system.in. Then we can just put like string s1 is equal to in.nextLine, right? Because in this case, we don't need to separate the score from the name. We can just output the entire thing together because we don't need to like manipulate the numbers or anything. So we just do that for all of them. And like technically you don't need to create these strings. So I'm like creating these. So if I create like 5 of them, I can output each of the 5. Another thing you can do is you can just do system.out.println in.nextLine, and then it'll output the next line like automatically. I just have a habit of assigning variables because it's like in case I need to use it again later on, it's a lot easier that way. But for this question, if we have string 1, string 2, string 3, string 4, string 5, and we rename these variables. And then system.out.println s1, and then we do this 5 times as well. And then like it seems tedious now, but later on we'll also learn how to do loops, which will make these kind of processes a lot faster, and you don't need to worry about copying and pasting a lot of code. But for this question, it's like basically the first one, except for there's multiple lines. So you just need to create a bunch of like different strings if you do it this way. The third one, basically, I'm actually not okay. I won't do this one just because it's like pretty easy. It's like basically the same thing as the second one, but basically you do the same thing. But if you wanted to, you could also do .next int, because these are integers instead of .next line. But no matter what you do, you just print out each one of these lines as they appear for the output. You don't manipulate them at all. And then for Tidy Printer 2, for this one, this one's not too bad either. We can create our scanner. And basically, for this one, I would just put like int number 1 is equal to in.next int in.next line. And then like you do this for each one of the numbers. So this would be n2, n3, n4. Okay. And then when you output it, you would just add like spaces in front of them. So it'd be, the first one would just be n1. The second one would be like a space plus n2. And remember what we talked about last week, which is that because this like you can combine a space, which is a string in this case, with this integer, and they just concatenate it together. And then for this question, you would just do it for all of them, for each one of the lines or each one of the numbers. So 1, 2, 3, 4, 5. This would have 2. This one have 3. This would have 4. 3, 4, 5. So if we submit this code, it works for both of the test cases. And then the last one we did, this one basically, you do the like very similar thing. You create a scanner first. And then you do integers, or actually you would do doubles in this case because it's like they're decimals. So you do double n1 is equal to in.next double in this case, right? And like for example, the past couple of questions, instead of doing .next int, you could do .next line because you're not doing anything with the numbers. So saving them as strings doesn't really matter, right? But in this case, because we have to add all the numbers together, you have to save it as a double, in which case we have to use in.next double and we can't use in.next line, right? And then we would do something very similar to like the last problem where we would just save 5 of the numbers. So n1, n2, n3, n4, and 5. And then remember, we need to do in.next line for each one of them. So that way it moves on to the next line so it can read the next number. And then finally, this case, we would just add n1 plus n2 plus n3 plus n4 plus n5. And because they're all doubles, instead of treating them like strings and then just adding one after the other, you add the numbers all together and then it turns it into a string. So ultimately, when you output it, you'll output the sum and not just one number after the other. And so for this case, it works. Okay.
Oh yeah. Also, one thing with this code is, can you scroll down? So like since you're reading in like doubles, you don't have to write the in.next line every time, because the in.next double will just go to the next token, which is on the next line. Yeah.
Oh.
You only have to do you only have to do an extra in.next line if like you read in an int, and then from then on you're doing in.next line. Then you have to move to the next line to read in the full next line.
Yeah. All right. Thanks, Victor.
Wait, could you re-explain the in.next line one more time? Because I'm a little confused about it.
Yeah. So basically, for most of the methods like next int, and next double and next long, they basically take the next token. It's basically the next like space separated or line separated thing in the string. But in the next line, what it does is it takes where the cursor currently is and it returns everything until the next line. So like if you have like a few
Yeah, so for
wait.
like for this problem, for example, wait, actually, let me. So if for example you were reading this dot next double, your cursor would go from the very beginning to the end here, right? And so if the next thing you want to read is dot next line, what it would do would be like it would read from where the cursor is to the end of the current line. But in this case, because there's nothing after 12.1, dot next or if like trying to save dot next line wouldn't save anything at all because there's nothing left on this line. Does that make sense?
So like you're trying to read what's ever like past the line, right?
Whatever's left on the line.
Okay. And you like only need this when you're like can you explain like when you like need it?
Okay. So basically the only time when you need like a wasted in the next line is when you're trying to just move the cursor to the next line. So if you do something like n equals in the next int, and then you want to move to the next line to start reading one line at a time, then you have to do like a wasted in the next line just to move the cursor to the beginning of the next line. Yeah.
Okay, so that's the purpose. Okay, I think I get it.
Okay. So we went over the problems, and now we're gonna go over. We're gonna go over what we're gonna do today. All right. So today we're gonna go over 3 different concepts, which are like by themselves like pretty easy, and then you like apply them together to solve problems. So it's gonna be variable, typecasting, and operators. Okay. And so an introduction to variables is basically Java is a statically typed language, which means that if you declare a variable like an integer, it has to stay an integer. You can't change it to a double, for example, right? Some other languages like Python would just have variables, which means they can change like over time, right? But Java, once you set it to a certain data type, you can't change it. So an example would be if you have an integer called n, you can't set that equal to 3.7 no matter what because it was declared an integer. Okay? And there are 2 different types of data types in Java, just primitive and non-primitive. You guys should have looked at like at least one form of a non-primitive data type in string, but primitive data types are what we're going to focus on for now, right? And those are the ones that Java has already like in place. So those would be the ones where you don't actually need to create. It would be like in this case, you would have Boolean, char, which is like character, byte, short, integer, long, and float and double. Okay, and then you can split these primitive data types into different categories, right? So Boolean type would be true/false, and it would be the only one of its kind, right? And then numeric types has different kinds, and one would be character values, and so that would be char, and that would be like A or B or C, just like one letter, or you could put numbers relating to like what letter those relate to. But for this like for today's purposes, just assume that char is just like a single letter, for example. And then we have integers and floating points. And so integers are basically no decimal points, and there are different sizes of primitive data types that are integers, and they increase in size. So basically, if you want to save some space, you would use a primitive data type that requires or that can store less, right? So using a long to store like a small number would probably not be the best way to use the space that you have. And this gets very important when you get into like later competitions when they have constraints on how big or how much space you can use for a problem. And then the last one would be floating points, and would be float and double, and those would be the ones where you can have decimal points. And like the integer data types, those also have different like sizes, or they take up different amounts of space. So you use different ones when you in different kind of circumstances. Okay. And then non-primitive data types, we'll look at most of these like later on. We have like string, array, and there's like a whole bunch like other ones like maps and like array lists. But like for now, we don't need to worry about that. Okay. And so there are different primitive data types, and like this is what I was talking about. And so for like in this chart, you can see the different data types and their sizes. So for example, byte would be the smallest like one for integer data types, and those can only store whole numbers from -128 to 127, right? And then it increases in size all the way to long, which takes 8 bytes and can store like super big numbers. And of course, if you need to go bigger than that, there are different methods that you can use to store those kind of numbers. But for now, especially since you guys won't be doing like any competitions that require you to store those big numbers, you don't really need to worry about that. Long should definitely be enough. And then float and double would be the ones with the decimal points or fractional numbers, and they have 4 bytes and 8 bytes respectively. And float can store 6 to 7 decimal points, and double can store up to 15 decimal digits. And then finally, you have Boolean and char. Boolean would be true or false, and then character would store a single character or letter. Or, like I said, you can have numbers which correspond to like a character's ASCII. I actually can't. Okay, I can't think of what A is, but like for example, if you put like a certain number, it would store it as like a character. Are there any questions? So this is just talking about how we have 2 different types of number data types. There's integer types, which is whole numbers, and floating point types, which is fractional numbers. And then Boolean is true or false. Character takes in a single character, and you like, okay, so for integers, you basically just set it equal to the integer. So you would have like int n is equal to like 56. For Boolean, you would do like Boolean a is equal to true, or Boolean a is equal to false. For character, you put single quotes around it to signify that's a single, like it's a character and not a string. And if you use a string, you would have double quotes around it. And we'll go into string and arrays in future lessons. It's not something that you guys really need to worry about too much right now. It's just a good idea to know how to like initiate a string data type. And then the next concept that we're going to look at is called typecasting. And what typecasting is when you change like a value of one of a variable from one data type to another. So for example, if you want to turn like a decimal to like a 5.8 to an integer, you would be typecasting that. There are different types of typecasting. There are 2 types. There's upcasting and downcasting. And upcasting is when you turn a smaller data type into a larger or a larger type size. So if you turn an integer into a long, you can automatically do that. You don't need to do any kind of like special things, right? Because an integer is inherently smaller than a long data type, which means that like if you have int n is equal to 5, you can do long I is equal to n. And it would automatically work because int is smaller than a long. Downcasting, however, you need to do it manually because otherwise like it just doesn't work. So for example, if you want to turn a double into an integer, like if you have double n is equal to 5.8, if you want to convert it into an n, you need to do that manually. I'll like later slides, I'll show you how to do that. So for upcasting, for example, if you have int n is equal to 5 and you create a double called new n and you set that equal to n, you don't need to do anything special. You can just set it equal to n. And then when you output it, n would output 5 and un would output 5.0 because un is a double. But downcasting, for example, if you have double n is 5.83, you need to do like parentheses like in front, and then like the data type that you want to convert to in front of the variable that you're converting. So for example, in this case, you would have int new n is equal to, in parentheses, int n, and that would convert the n into like an integer data type. And you'll see that when you convert from a double to an int, it doesn't actually round the number. Instead, it just drops all the unnecessary like decimal points. So it would just drop the 0.83, and you would just be left with like, so you wouldn't use int, you wouldn't typecast, or you wouldn't downcast from double to int in order to round. That's not how you round in Java. So some things to note is that when you're typecasting from double to int, everything after the decimal point is lost, which is shown in this example. And another thing is that sometimes when you downcast, you can result in like unexpected values. So the reason for that is because your different data types store different amount of like data, like have different sizes. So if you have like a long that's like 9 million, and then you try to convert that to an integer. Let me see. Yeah, if you try to convert like long, like 9 million, and you try to convert that to an integer, you would get some like weird, unexpected 9 billion, for example. I mean, you would get like weird errors, or you would get numbers that you don't expect. So that's something you need to look out for when you're downcasting. Upcasting you don't need to worry about because it does automatically. Are there any questions about typecasting? Okay. So the next thing we're going to learn is called operators. And so operators are just how you like perform operations. So it would be like addition, subtraction, and then there's like a bunch of other ones that Java has, like comparisons. And so there are 5 different kinds that Java has. We'll focus on the first 4 because those are the most important when it comes to like HackerRank and USACO and those kind of online competitions. Arithmetic operators are pretty self-explanatory. You have addition. So if you have int n is equal to 5 and int j is equal to like 3, if you add the 2, you would get like 8, right? So you just do like n plus I, in which case you would get like 8. Subtraction is also pretty easy. Multiplication is easy. Division, something to note is that if you divide 2 integers, you end up with an integer, which means that it won't like you won't get the exact answer. And so if you want to get like proper division, you have to first convert one of the integers into a double, because a double divided by an integer gives you a double. So when you're doing divisions, be sure to make sure that if you want the exact value, that you don't have 2 integers, or you need floating point values basically. Modulus basically gives you the remainder when you divide it. So if x in this case is 5 and y is 2, the remainder would be 1. So 5 mod 2 would give you 1. Increment increases it by 1. So you can do plus plus x or x plus plus. So if you have int x is equal to 1 and you do x plus plus, that'll increase it by 1, and then x is now 2. And then decrement does the exact same thing except for it decreases. In this case, for example, you have int I is 5 and double j is 2.2. And you'll see that here, because you're subtracting int and a double, you have to set that equal to a double. So double k would be I minus j. It would output 2.8, right? And then here, we're changing what k is. You set k is equal to I times j. So then you multiply 5 times 2.2, which is 11. But because k is a double, it outputs it as 11.0. In this case, this is what happens when you divide 2 integers. If you have 39 divided by 5, it's 7.8. But because they're both integers, you just drop it just automatically drops the 0.8, and you end up with 7. So if you want to get the exact value, we would turn the I into a double by typecasting it, and then we would divide by j. And in this case, typecasting takes precedence, which means that when you put double in front of this I over j, you first convert the I, or it first converts the I into a double, and then it divides. It doesn't divide and then typecast to a double. Okay, so that's why this line of code works to get the correct answer. Are there any questions about what we've gone through so far? No? Okay. Assignment operators are basically ways to change one variable. So we would have, this would be like setting a variable to a number. So you would do x equals 5. X plus equals 5 increases x by 3. X minus equals 3 decreases it by 3. And so you'll see that these two are different from x plus 3 and x minus 3. So x plus 3, you would have to do like x is equal to x plus 3, right? Which is the same thing here. But if you just do plus equals 3, then Java knows that you're trying to increase x by 3. So it just takes less time to type it out. And you can do all of them for the arithmetic operators. Like here you have addition, subtraction, multiplication, division, and you have modulus. And then this is and equals. I don't think and equals like not very useful. I don't like. It's something that you can try to like learn, but the ones at the top here are probably the most important ones that you should know. Okay. Are there any questions? Okay. In this case, we have int I is equal to 5. I plus equals 2 would be this assignment operator here, and it increases it by 2. So when you output I, it becomes a 7. And then you have I multiplied equals 5, and this is the same assignment operator as I is equal to I times 5. So you multiply the 7 by 5 and you get 35. And then the last one is comparison operators, which allows you to compare two things. So if you have Boolean n is equal to x greater than y, if x is greater than y, then Boolean n would equal true. Otherwise, it would like equal false, right? And so these are ways you can compare two different variables. So for example, if we have Boolean n is equal to 5 equals 2, we know that 5 equals 2, like, and you would also do 2 equal signs in this case, right? Because that's the operator. So if you have 5 is equal to 2, that's obviously false. So Boolean n would be false, right? But Boolean I, 7.2 is greater than 2, so Boolean I would be true. So when you output n and I, it would be false and then true. Okay.
Oh, also we can you stay on the slide? So I want to clarify like a difference between like a single equal sign and a double equal sign, since like that might be confusing. So basically, when you see a single equal sign, what that means is it basically evaluates the expression to the right of it, and then it assigns that value into the variable on the left. So in this case, it would evaluate 5 equals 2, and it gets false, and then it assigns the value false into the variable n. But on the other hand, the equals operator basically just compares the equality between the two values on either side of it.
Yeah. So for the first line, you would first do the comparison, and then you would assign n to what that comparison is. So that's basically all for today. We went over variables, typecasting, and operators. I'll post a link to the contest in the chat. You guys can get started, and then we'll stay on. And if you guys have any questions, feel free to ask. And actually, that's not the right one. That's my bad. Okay. I posted the link into the chat, so you guys can sign up and start working on it.
I have a question over last week's PowerPoint.
Yeah, what's up?
So can you please pull it up, and I would like to discuss a problem.
All right.